Hello folks, well I was going to do the Unit M300 base station so we could copy the wiring and get the one back to our customer, but something else came up on a comment. We're going to do this York 861 in the box, but there's two things to do first. We've had the brackets from Brickworks, they're CB007 at Holmfirth. Simon runs that business. These are exact reproduction brackets for the communicators NI440DX, the Manor Kestrel, the the Serpent UK4000 and the Planet 2000, and they're black powder coated as the originals were, and that is how they should be. I don't think I've got any side screws on here. I've got one. Wonder if that fits this type of radio. Let's just have a look. No, that's too fat, so it's not going to go through there. Anyway, they are exact reproductions, so I'm pleased to say that. Did I say they've got a part number? It says CB7, isn't it? CB007. It sounds like James Bond. So we've got a couple of samples from them to help our customers. And something else has cropped up with the same radio. We might have got relays for them. This might be the relay. Now, we had to pinch one out of one of our own sets to help a customer recently. Now, I've got one of these in stock, and I was able to order it from the United States as a Canon photo flash part. And they certainly know how to charge, and we're going to have to prove that on a video, but I think it's the same relay, because this time, Canon, the Canon one works out at $29.95, which is a horrendous amount of money for a relay you expect to be £5.99. But I've ordered this from Japan as a Pioneer part for a stereo system, and it's the same relay. I'm going to prove it on a subsequent video, and they're $12.99, so it's still too expensive, but the blooming big difference, isn't there, between $12.99 and $29.99 for the Canon one. So some lucky customer can buy my $29.99 one, but at least we've got them. So I'll put that to one side. So that's the thing I wanted to discuss first. I'll just put that up there, the bracket somewhere where I'll never find it again. And then something else has arisen, and this is why we're doing the York. One of the viewers has put a comment about, he's got a Rotel 230. Oh, that's a 220, that's not what I wanted to show. He's got a Rotel 230 and he's not got transmit. So I said on the comments, well, plug the mic in and check it in public address mode. And of course, to his delight, it works in public address mode. But what I wanted to prove, and I can't with the set we've got here, and this is from Mr. Trucking and Farming, I wanted to prove about the way public address works on the Cybernet 134 chassis. Well, we can't do this because these don't have public address. It's another immaculate set with a factory original mic. But I'm going to nevertheless do this as our next job, because if it works on public address and it doesn't transmit, this is the next thing you've got to do. Let's get our duster out. I've done 2 church services a day. I'm absolutely knackered. One was a baptism and I had to lend them 35 hymn books, or boxes of great big thick hymn books down a long driveway. Right, so I've got this immaculate York 861. What I wanted to do, and we'll probably introduce another video with it, is when you're in public address mode, I don't know whether I don't quite know how they do it without looking or demonstrating. What I was going to do, I was going to take the transmit wire off inside the mic and see whether it still went into public address, because I think there's a possibility it solely relies, when you're in public address mode, on the fact that when you press the PTT, the microphone audio element is connected to the radio, not the actual switch doing any switching. So you've two poles of switch, haven't you? So we're going to go into this in more detail. There's still a possibility that the gentleman who's got no transmit on his Rotel 230, it could still be a faulty mic. I've got to prove that with a set. I might have done this 40 years, but I can't always remember everything on everything. But what if you have got no transmit? We're going to go into bigger detail than we usually do, and this is why I've done this out of sequence to kind of prove that. Let's get the clipboard out. I don't want to kind of make this into a very, very long video. I'm very pleased that Simon at Brickworks has done that bracket. We've got his Cybernet Beta 3000 we'll be doing in a couple of sets. I didn't want to do it straight after that one which came out of a skip. So it's the 31st of August 2025. It's a York JCB861. I'm not expecting any shenanigans with it. And I'm just going to show a little bit more of the VCO setup. I can't even read the serial number. 646. So it's trucking and farming. So we'll power it up as it is. I've only just put the test gear in on, so we're going to not worry so much about what frequency it's going to be on, because that's going to be 20 minutes warming up. And we need a suitable power lead, and we usually have a little stub on here just to do these. I'm still stacking jobs on here because we've also got this Thunderbolt T800 lid belonging a blown up set which has been on 36 volts. I'm waiting for Thunderbolt to get back to me if they've got newer circuit diagrams in 2019, because that's the current version, and Thunderbolt say we're getting onto the factory to make them for them to see whether they've got newer circuit diagrams, because they haven't got newer ones either. So there you go. Right, so here we are, connected up to the York JCB861. Put the power supply on. It's not a new in a box set, it's very good condition, and there we are. Right, so we're connected to our test gear, and here's the thing, you can't really do this on an aerial, it's got to be done into a dummy load. So, you know, if you haven't got a dummy load and you're wanting to try and work on CB radio, there's a video on how to make a dummy load using a PL259 plug, which I did some years ago, and some resistors, and so that's a cheap way to do it. But you can buy a dummy load relatively cheap, at like £5.99. I've had them from AliExpress, because at the end of the day you don't need it to be, these radios are 4 watts outputs, and even when radios are in a tune-up procedure, they're never going to go over 7 watts. So, you know, certainly a 10 watt dummy load, even a 7 watt dummy load would suffice, but a 5 watt one wouldn't. You know, in America they had some cheap and cheerful light bulb ones. They will pop on a lot of UK radios, especially if I'm showing you real watts and not fictitious good buddy watts, which I am. So I haven't got one to show you, but you have to do it with a dummy load. So there you go, that's your first purchase. We've got this a series I did some years ago, shoestring budget of doing repairs, and a lot of this is on there. Right, so we're on, and we're lit up. We're on channel 20. Let's put picture in picture on, and key it up, and hey presto, we've got. You know what? We're going to put 3 watts down for that. 3 watts. Channel 40. You know what? It's 3.05 watts. It's just past full scale deflection. Channel 1, 3 watts. They're not usually that way round. Right, go to low power. It's on the front panel on these, isn't it? And we're doing 110 milliwatts. Go back to full power, check the current consumption, 914 milliamps. Deviation, this meter may not tell us the truth, so we use a different one for the calibration. Wallow, it says 1.8, which I can believe. Let's put down 1.9. We're going to do the VCO, we're going to spend time doing that. I'm going to show the frequency, and we'll just see whether we're going to be anywhere close. 27,79098. So that's 27,79098. It should be 27,79125. Anything over 100 is okay. There's plenty of leeway, but we want it to be as close to that as possible. So we're going to put that now into the signal generator. 2779. You can hear it receiving. I'm deliberately putting it off frequency to the same amount, so it's a fair test. That's absolutely fine, close enough. And when we key up, let's just go back to transmit. When we key up, what does the meter say? It says 3.5. So that all get calibrated. 3.5 meter lamp works. And remember, these meters are subject to SWR. So into a dummy load like we're doing at the moment, it's going to read what you'd expect it to read. But if you have it on aerial, with that same power output, I could key it up and the meter would hardly move. It might only go to 1. Conversely, it might bang across. It's subject to SWR. Doesn't mean you're doing less or more power because it's subject to SWR. A lot of new sets, and I can't think of any except the Midland 78, don't use real power meters. It's pre-programmed, and that's sad because you get a set with no transmit, and the bar graph is banging across as if it's transmitting. You think, why am I not getting out? Because it's a fake meter, and they're all doing that. Okay, we don't have public address on this one. I can hear the speaker working. The sockets work because there's only 2 of them, and we're just going to plug the test equipment in to the extension speaker socket. And let's have a look at the receive figures. Put the SINAD meter on. I'll tell you what, this set's working very, very well on receive. 12 dB 0.24, 10 0.22, and 20 0.43. Squelch, I've put the squelch to full. Let's just show you the attenuator on here amongst all the wires and debris and crud. It's this one I want you to see. So we're at 1 microvolt at the moment. I want the squelch to open at 100, but there isn't a hard and fast rule on this. 3, 10, 30, 100 it opens it, which is how I want it to be. However, that will change when we've done the service and I'll have to reset it. So we're going to do the opposite now. I've parked the signal generator at 0.3 of a microvolt, turn the squelch down, set the threshold on the radio. The threshold is when the background noise just disappears. Switch the signal generator on, and we see when it comes in, and it is 0.46. That's really good. I'm going to take this back to 100 microvolts, which is the equivalent of an S9 signal for a CB radio in the UK, not for a ham radio, and it's nearly bang on 9. It isn't quite, so we'll just find out where it's currently calibrated, and the answer is 155 microvolts. So it's a little bit on the lazy side. So now we're going to open it up, and I'm going to show you in more detail than usual the VCO, because this is, if you've got no transmit and the radio's going into transmit. So do these have a TX light? No. So if you've got a TX light and you press transmit and it glows red, you know it's actually going over to transmit. So you haven't got that on these radios, on this particular model. I think you have on the Rotel 230. And that's something for that viewer to check, that when he goes into transmit, if the red TX light comes on or not. We can disconnect the internal speaker, and someone's put green and yellow already there. So I just have a quick look to make sure there's no capacitors which are bulging. So here's the thing, we need to go to channel 40. So we've got 40 on the radio. This is the VCO setup. You do need to use a digital meter, and this is why we use this £16.99 meter from Lidl, and we've got a £16.99 one from Aldi. We've also got on the bench behind a more expensive 10 mAh one, they're probably about £60. And then we've got a £120 10 mAh true RMS meter for other types of readings which we might need. And on the bench in other rooms there's a Keithley, so there's an £800 meter. We've got no, I don't do Fluke, because Flukes have done the Philips brand and I'm not a big Philips lover. But they're the industry standard, but I don't care an iota. I don't need to do that. And our test set, when we tell you how many watts it is, it's the same as what would be on a Bird through line 43 with the appropriate element for covering 27 megs at 5 watts. So that's why it's a different type of reading that you're going to get on a hobby meter. It's always going to be lower. It doesn't take the interference into consideration. So we're connecting our negative probe with a crocodile clip lead to this strap across here, because that's the earth. The chassis is not earth on these radios. Switch the meter on, and this one's also ranging, and what we're looking for, and I'm going to zoom in, which I don't do often but we will do, let's make sure we're on the right camera. We'll just zoom in because you're looking for resistor 4. And resistor 4 is here. That is resistor 4. And I'm looking at the far side. So I've got the radio facing towards me, the knobs are towards me, the front is towards me. This is the front side, this is therefore the far side, and you'll see on the meter, let's go back to our full picture, you'll see on the meter I've got 4.06 volts. That's exactly what the service manual says it should be. It should be 4 volts. The fact it's 0.06 is neither here or there. If we're building a space shuttle, it might be important, but it isn't on this. Go into transmit, and we should also have, oh, we're going to have to connect our earth, which you won't have. I'm going to have to disconnect our extension speaker, which you don't need to have. And we should also have 4 volts in transmit, and you'll see it starts off about 4 volts. It's dropped to 3.92. That is absolutely fine. I don't need to adjust either of those. They're absolutely fine. But you'll see you've got the trimmer capacitor, the red trimmer capacitor at the back there is the transmit one. The manual says to do receive first. And let's just do this. I'll just show you these. You can't use a screwdriver. They're supposed to be either plastic or ceramic trimming tools. You can get these from AliExpress for a couple of quid. It's I think it's 1.6mm blade. 1.5 I think this one. But with the appropriate tool, we can put it very, very carefully in there and feel where the point is it goes in, and you can see with the very finest adjustment, to the left it's gone higher, doesn't mean it will on your set, to the right it's gone lower. We can just return it back to, these are very, very fine adjustments. We're at 4 volts, back into transmit, it's slightly changed, you see, it's 3.8, that's absolutely fine. Now we're going to go to channel 1, and this is your check, because it needs to be between 1.8 and 2.35 I think it is. So we check again, and on channel 1 we're at 2.06 in receive, and in transmit we're at 1.99, absolutely as it should be. So you may come to a situation where you've got receive and that voltage is correct, but you might find it's 6 or it's 0 or something, in which case you're going to adjust that trimmer capacitor to try and get that right. So there you go. Once he's actually transmitting from the VCO, you can actually have a walkie-talkie or another radio at the side of you, and you'll hear yourself coming, just even if the thing's not transmitting because the transmitter's broken, you will hear yourself transmitting. Let's go back to channel 20, and the battery's flat in this. Testing 1, 2. You will come through your walkie-talkie even if the transmitter's broken, just a few inches if the VCO's set right. So there you go. We'll just go through this in now the normal case. I don't need that anymore. Just get this transmitter tuned, and then it's tea time. So again, these trimming tools are available. This is the Velleman VTPT kit, which are available, but they're a pretty penny. And our friend Gareth in Leeds has made these copies because he's kind. So what we're going to do is shut that up. We're going to show you the main meter. We're going to show you the main meter. There we go. We're on the 3 watt scale, and what I'm trying to do is to get this to be absolutely centre of the peak. We're on channel 20, we're in the middle of the band, and we're virtually at full scale deflection. That's the centre of the peak. I've got to detune it, to retune it, to make sure. And the third one there is the centre of the peak. With no change, it's still doing 3 watts. I'm going to have to change scales now. And on my test set, my second scale, I've either got the 3 watt scale, which we've been using, or the 30 watt scale. So now everything is down here. That's my 5 watt point. This test set's intended for business radios, and in the UK business radios go up to 25 watts. So, peak on the yellow one, that's brought us to 4.1. Peak on the centre one, which is supposed to be white. You've got to do this quickly, and I'm unkeying in between. You've got to do it quickly because the radio is going to go over 4 watts, and these 3 coils and that radio frequency choke down there can melt. And they can melt in 30 seconds. So we're at 4.6 watts at the moment. So I'm going to check they're at peak again, because they are interactive. And the green one. Right. And now what you do is the yellow one, you don't leave it at that or it will melt the transmitter. So then a few days later of getting an extra 100 yards range for that extra watt, you will find the PA transistor failed and all these coils melted. So we want 4.4 watts, which we've now got. And then what we do, that's clockwise. You're turning it clockwise from that peak to 4.4 watts. The green one, you turn anti-clockwise, and that's for 4. The service manual says 3.8, but that's because they need to get them through customs. We're entitled to 4 watts, and we're jolly well having it. So that's it. Now we're going to recheck that it's within 1/10 of a watt on all the channels, just simply by going to the band edges. So we know it's 4 watts on channel 20, channel 40, it is 4.05, channel 1, it's 4. So there we go. That is very well within. So we've now got 4 watts, 4 watts, 4.05 watts, and the powers that be aren't going to come down to your door nobbling you for 0.05 watts, I can assure you, but they might do it for 40. Right, low power. Now these presets get dirty. So we're going to use the Servicol Super 10 switch cleaner. Just pop some on there. Now the other thing that can happen, let's go back to channel 20, is they can break. If you've been using low power a lot, they can actually physically, the track melt on them. So we're going to now just waggle that round, transmit. I'm back in the 3 watt scale, and you're supposed to set this for 400 milliwatts, so 0.4 of a watt. So on our test set, if 3 watts is full scale, 3, 1, half a watt, we're looking at their 0.4. Well, there we are, we're set. .400 milliwatts. Now the other thing I'm going to do is we're just going to check if what the current consumption now is. So when I started off, for that 3 watts output, it was doing 940 milliamps, so just under 1 amp. So I just want to look at my power supply now when I key up. It's 1.135, 1.135, and that's what you'd expect. If you're kind of drawing 1.5 amps and it's only doing 3 watts, something's wrong in the tuning on these kind of sets. Newer sets draw more current because they're controlled by CPUs, and that doesn't make them better, I can assure you. Gives them more pointless features. And we're just going to finish off before my tea by setting the meter for the transmitter. So if we key up, it's supposed to say 4 into the dummy load, now says nearly 5. It isn't doing 5 watts as we've just seen. So that preset at the back there sets the meter. Doesn't set power, just sets the meter. Right, I'll pause the video and we'll come back to that when I've not dropped my clipboard on the floor. Okay, I am back, and we're now plugged into the deviation meter behind me. We'll just see what the deviation really is. Well, it's about 1.9, which is what I think we got on the Marconi. I just want to set that to centre position. I've said before, the European version of these never had this preset, and there we go. And then we'll do the deviation on the deviation one. Look, that's it. Right, we'll plug back in to the Marconi test set. We'll see what the deviation says on this one. Wow, it says the Ross it's 2.2 to 2.5. Everything's in sync with everything today. So it's 1.9 kilohertz, it's now 2.2 to 2.5 kilohertz. We'll do the frequency. Let's go over to the frequency counter. We want 27.79125. So, I mean, it wouldn't matter, but we'll pull it up seeing as it's here. Red trimmer just there with the reference crystal. That's a little bit high. I like to have them slightly high, but probably not that high. 27.79126. I like to have them high because they drop with age. 27.79126. That's absolutely ideal. So now we will set the signal generator to the same frequency because it was off frequency before, so we deliberately got the signal generator low. So bring that up to the correct frequency, tune the receiver, which is already very good. First thing to do is to put the extension speaker to the test gear back in. Bit of noise on that volume control. Is it a type we can easily do? It's not the type that is easy to do. We can give it a go. Right, so we want the oscilloscope on, and we want to maximise that trace on the oscilloscope. Make sure it's peak. It was minutely out, not a lot though. So I'm going to do the IF, the intermediate frequency. We've got two on these. On posher sets in the range, you've got an extra one there. So I'm looking at the oscilloscope, I'm looking at the SINAD meter, and I'm looking at the meter on the front of the radio, and I'm also trying to find the right camera. I'm dropping the signal to about 18 dB on the SINAD meter. I'm just going to check these IFs. That one was slightly out. I'm going to drop my signal again because we don't want to saturate the receiver. You know what, that was very slightly out as well. So now we're going to be solely on the SINAD meter drop that to about 5 dB, 6 dB. I'm going to go through these, start by that one. Somewhere under the wiring there is one. There's a little bit out. Drop the, had to change scales, drop the SINAD meter again. That was spot on. See if I can see that on the meter. Right, we are at peak. We'll read off. And hopefully it's even better from how good it was anyway. So for 12 dB we now got 0.23. And the signal generators decided to change frequency. Okay, so we'll go for 10 dB. It's 0.2. We'll go for 20 dB. 0.37. I'll put 0.38. So we have managed to get a bit more out of the already very good receiver. Might make another 6 inches of range. Let's do the S meter on the front panel. You know what? It's bang on now. Now we've realigned it, it's bang on. We would adjust it to S9 with the preset just here, but we're not going to touch it because it's spot on. Squelch. So put squelch to full. Signal generator. Let's go over to the attenuator so you can see what I'm doing between the wires. So once again I want the squelch to open to 100 microvolts. 1, 3, 10, 30, 100. It's spot on. So I haven't needed to adjust that either. So we're going to do what we did first earlier. Set the threshold on the radio with the signal generator off. That's now on standby at 0.3 microvolts. Put the signal generator back on. And let's see where the squelch is now. 0.51. 0.51 microvolts, 100 microvolts. S meter, we've set that to read 4, and the S meter is now at 100. And there we go. We're set. We'll test his microphone on the air test, during the on the air test, at the end to our base station. So the whole point of this was the gentleman reported he's got no transmit on the Cybernet 134 set, which is a Rotel 230 in his case, which is why I've gone through the VCO in greater detail, and it's exactly the same chassis on the road on all the Rotels as the York 861 and the York 863 and the York base station, not the York 867, which is a dreadful radio. Which is the same as a Murphy DS602. This is a really good radio. Right, we'll get the screws back in there. Bit of noise on the volume control. Hopefully I've got some switch cleaner in that. And then we'll do an on the air test. And it's going to work splendidly. Right, so I'll unplug the test equipment and we'll plug in the roof aerial, which I keep telling everybody is a Solarcon 99 without the optional ground plane kit. So it's 6:30 on a Sunday. They're probably all at church. One on a Roger. Alright, there we go. Cybernet 134 set, and it's as a York JCB861 from 1981. Thank you for watching.